And then, in addition to that, we have the ability to aim antennas without domes. This is one of our most popular systems. It's less expensive than the dome systems, and is a good high-functioning system. And then we have the next system up, gives you the ability to, on our 50-pound pan tilt or aiming system, we've done integration with Bridgewave and gigabit radio technology. Here we've got the ability to aim, like for example, the Bridgewave on their 80 gigahertz system with the 2-foot antenna. The beam width on that antenna is 0.4 of a degree. 0.4 of a degree beam width. And people have wrestled with those for a day and not gotten a great alignment. You can imagine with a beam width like that, you've got to be awfully lucky and precise. We can get a great alignment with that, with a perfect alignment with gigabit throughput in under 5 minutes. And so we have the ability with our heavy payload systems to aim any broadband radio antenna combination up to 500 pounds. So whatever the need, we have the ability to aim it and then initiate tracking. Now, some of the big dishes that we've done, they've been at great heights, and there's a lot of wind. The dishes will get blown off because of wind. Our system constantly monitors that signal, so as there's a need, it will automatically realign if it starts to get blown off by wind or other factors. It will auto-correct back to the best possible signal. These are really what our system components make up. They're a pan tilt aiming device. These are our non-dome systems that connect to either a rack mount or a hardened control unit via a proprietary power control cable. And then up here on the arm of the pan tilt is where we put the radio antenna bracketry. And there, that's where, we do the aiming. And then we do have, for the narrower beam antennas, we do use GPS targeting to get us in the right area code before we initiate the scans. And then we also use this for offshore for stabilization to accommodate for the movement of the vessel, or in high-speed applications to accommodate for the movement of a vehicle. As I mentioned, we're radio agnostic. Here's just a list of some of the leading radio manufacturers that we've integrated with already. We work very closely with these radio companies, as well as a couple others, where we've done all the integration work. They continue to get us their latest firmware, and then we work closely with them to get the best possible speed of communication with their radio. We, on average, ping a radio once about every 100 milliseconds for information, and that's how we're able to keep it in perfect alignment even during mobility. Now, let me just go through a couple, run through some case studies really quick of where we have recently done deployments. You all remember back September 11th, 2001, the terrorist attacks, the emergency response network basically was shut down because of there was just so much traffic. They're now in the process of finally, getting that rectified. In that, this is a project we're doing with Motorola, and there are 10 buildings amongst the 5 boroughs. The first one was the Empire State Building, where they're putting one of our systems up on each of the 4 corners of the 10 buildings, and then each of their mobile command units, their first responders. This particular one was for the medical examiner. was the first deployment we did. We'll be outfitted with one of our dome systems where it'll automatically do the alignment to the closest connection of the 40 access points that have our systems throughout the New York area. The first test that we did, we were able to deliver 110 megabit of throughput on a 7-mile shot from New Jersey over to the Empire State Building in a really, really hostile RF environment. So that's one of the recent cases that we've done. Very similar thing was done for Louisiana. It was actually Lafayette Parish down Louisiana. Same thing. They have 6 towers around the parish, and then this is a picture of their mobile command vehicle with our system up top. And that mast extends, and then wherever they are within the parish, they've got immediate connectivity, and this is their redundant 911 call center. We also did the Toronto G20 Summit in June 2010. That was also a Motorola project. We provided the mobile command unit for the police department, Toronto Police, for the G20 Summit. Ship to ship, this happens to be with Redline. We were able to, between 2 moving ships, deliver 4.5 megabits with a maximum latency of 5 milliseconds out to 44 kilometers. That was for the Turkish Navy. We ended up winning that engagement. This was for a refinery in the oil and gas space, quick deploy. This is for a fleet of seismic vessels down in the Gulf of Mexico. This is one of the virtual private wireless networks at sea where ships are all communicating to each other. This was for the leading geoseismic companies in the world for their vessels to communicate at sea. It allowed them to be much, much more efficient, to be able to do shots out to 30 kilometers with 54 mega throughput, and it allowed them to process data while they were working. So in other words, before they had to wait till they were done doing their seismic readings and then begin processing data. They could not do that at the same time as they were working. Now they can process data while they're working, and it saves them. They claim to us that it has made them to the tune of nearly $100,000 more efficient on each operating day where they're working and doing seismic readings. So obviously it's been a very good economic proposal for them. We have systems deployed around the world, and we have channel partners around the world. So I told you a little bit about who we are, a private company focused on doing one thing and only one thing only, and that is delivering high bandwidth, communications, broadband communications for mobility and periodic realignment. And that's what we do. And I'll turn it over to Daniel or whomever is handling questions, and look forward to any questions that you may have.
Great. Thanks, Bill. Appreciate that. And you guys can see it really pairs up nicely with a lot of the wireless broadband radios that are out there in the marketplace for some unique applications. So we have a couple of questions here. The first one is related to 802.11n radios. Have you guys done anything with the new 802.11n MIMO technology where there might be multiple radio or multiple antennas connecting, and possibly in this application with a mobility with police car? Have you guys done anything along those lines?
I do not know. I don't know. I would have to talk with. Would that be, for example, the Motorola MPTP technology? Is that what they're referring to?
It could be that, or possibly they didn't call out a specific radio here, but an 802.11n with up to 6 dipole antennas.
We can do PMP. I don't know that. If you could send me that question, I'll get you an answer.
Okay, it looks like it is the Motorola radio at 7161. So we'll have to follow up on that. Okay,
all right.
Okay, the mobile mesh product from Motorola is what's being referred to here.
Okay. We have not. We have not. I can tell you, we have not. It's been their point-to-point series, the 500 and 600s. That's what we've done. Doesn't mean that we couldn't. We just haven't been asked to integrate with that yet for any projects. So the answer is no.
Okay. See here, gentleman asked for a copy of the presentation. We'll go ahead, and I don't think there's any objections with sending this out, Phil. Is that correct?
That's totally fine.
Okay, so we'll distribute that here this afternoon, most likely. Next question here. At what speeds can bats track for mobile applications?
Okay. A good rule of thumb, obviously it's going to depend upon the radio antenna combination. But with a standard radio, when I say standard, one that we have the ability to at least communicate with once every 200 milliseconds. In other words, read current data from what the radio is seeing or hearing once every 200 milliseconds, which is basically every radio that we work with. At 1 mile with a 6-degree beam width antenna, an object can be going 60 miles an hour completely perpendicular. So from left to right or right to left across the screen, 60 miles an hour at 1 mile. Obviously, the further out you go, the faster an object can be traveling. We have tracked for the Air Force with a military contractor down at a secure location in Texas, a 747. Tracked it all the way out to 209 nautical miles and picked it up at 173 nautical miles on the way back in. So that was with some serious amplification, though.
Okay. Next question here. How do you connect other hardware? Is it via Ethernet or antenna connections?
Via Ethernet. Am I answering? Am I understanding this correctly?
Yeah, that's the information. That's how do you connect to other hardware, radio/antenna, or is it via Ethernet or antenna connections?
Our system, we communicate via Ethernet from our control unit up to the radio, and we listen, via Ethernet connection into the radio, and then the radio connects from there out to the antenna.
Okay, well, I think that about wraps it up. Stuck to our time frame here, about 30 minutes. If you guys have any questions, my contact info and Phil's contact info on the last slide here. Feel free to reach out to either one of us, or if you have a dedicated partner development manager here at Moonblink, feel free to reach out to them as well. And again, appreciate you guys' time, and look forward to hearing from you soon.